All right, this is our review for chapter 2 for 2.3. This is our third part to these videos. So the first part of this, again, we're looking at postulates and diagrams, and it says state the postulate illustrated by the diagram. So on the first one, we have if, and they gave us a set of 2 points on a plane, then we have a line that goes through those 2 points. So again, the names for these are pretty straightforward. So I would think looking at this, let's say I didn't know my postulates and properties, I am talking about two things here. I'm talking about 2 points. I'm talking about a line going through those 2 points. So the name of this one is the 2-point postulate, and that's it. Again, some of these names are fairly straightforward. So again, for this one, it is simply the 2-point postulate. All right, number 15, sketch a diagram of the description. All right, this one, again, everybody's sketch is going to be a little bit different. All it says is that ABC is an acute angle and is bisected by ray BE. So for this one, if we were to draw this, and there's more than one way I can draw it because there's lots of acute angles I could draw. Well, let's say that's an acute angle, and then I'm going to bisect it. So I have on here points A, B, and C as being bisected by ray BE. That could be it. Let me use some lines here because that didn't look so good. What is this? Well, let's say I made it a little bit bigger. Great. It looks something like that. And I got some arrows on the ends. Let's say I relabel this. I need points there, there, and there. But let's say I label it the other way. A, B, C, and that's point E. So again, lots of different ways you could draw it, but something like that. And again, if you want to then mark them as congruent to 2 angles, that'd be good too, because again, it said that it's a bisector, so it should be split into 2 congruent angles. On 16, angle CDE is a straight angle. It is bisected by DK, by line DK. So we are going to have, oops, I clicked on the wrong thing. We're going to have a straight angle, which I'm going to do by doing a line. It is bisected, so since a straight angle is being bisected, we're going to draw 2 perpendicular lines. Because if a straight angle, which is an angle with a measure of 180 degrees, let me label this appropriately, C, B, D, glitching out there, E, let's just try that again, D. All right, so here's a straight angle. If it's being bisected, it's split into 2 congruent angles. So if the whole thing's 180, 180 divided in half is 90. So each of these should be 90 degrees, which makes them right angles. And I just need to put a point on here for point K. So this is line DK. And don't forget the arrows on the ends, because again, it is a line. On 17, plane P intersects plane R at line XY. Okay, I'm just trying to picture it in my head. All right, then we got segment ZW lies in plane P, and plane P is perpendicular to plane R. All right, so let me start with this piece of information. There's a lot going on here, but since the planes are perpendicular, I'm going to start by drawing a plane that is laying flat. Now, I'm going to leave a gap here because I'm going to have to draw another plane going through this one. And then let's say I draw this one here, back down. Okay, yeah, it's close enough to perpendicular. All right, so now we have our planes P and R. They appear to be close enough to perpendicular to each other. How to make sure they're perpendicular? I need a right angle symbol somewhere on here. If I want to put one here, we can, or we can do one on our lines later when we draw our lines. Now, for the first part of this, plane P and plane R. So, okay, I do need to label these. So call one of these R, one of these P. And we'll just go ahead and put a P on this one. Put an R on this one. Again, you could have switched it around. And they don't even have to be drawn this way either. So now plane P intersects plane R at XY, line XY. So the line that's connecting these, let me use the line tool this time. That's nice and straight. All right, so here's my line. Throw some arrows on the ends, and this is line XY. So put points on there, X and Y. Yep. And then it says ZW lies in plane P. So ZW so it doesn't say anything about this line segment and this line segment. They don't share any points in common. So we could draw it so that it goes either through this line segment or we could just draw it off to the side. It doesn't actually specify. So on here, I'm just going to draw mine off to the side. And just say, all right, here's ZW is on plane P, and that works. So again, just know there's more than one way you can draw a lot of these things. All right, let's move this up so that we can see the bottom ones. Clear. And I know I said it in one of the earlier videos, but again, if you're just looking for all the answers, again, the answers are in the back of the book. When we do these reviews, all the answers are posted there. All right, on 18 through 22, use the diagram at the right to determine whether you can assume the statement. 18 points A, B, C, and E are coplanar. A, let's circle these. Here's A, B, C, and E. Are they all on the same plane? Yes, they're all on plane P. So that is definitely a true statement. So it says, can you assume the statement? So we're going to put it in terms of yes and no. So yes. And if you wanted to say why, because they're on plane P. Let's see, 19. All right, let's clear these other ones off so I can redo these. Nice. There we go. So HC, this line's segment, this line going up and down, and GE. Here's GE. And they have this right angle symbol on there, right where they meet. So they want to know, are they perpendicular? Again, that's our symbol for perpendicular. So since they meet at a right angle, yes, they're going to be perpendicular because perpendicular lines are lines that meet at a right angle. All right. Again, let's clear that off. Next one, points F, B, and G. F, B, and G. Where's G? G. There it is. All right. And wants to know, points F, B, and G are collinear. So I definitely say that they look like they are coplanar. Now, are they in a straight line? That's hard to tell. But since there's not a line drawn through them, we can't really assume that. Now, using my line tool, I just want to see, does it look like they are? It looks like they're a little bit off. So again, even if it is drawn to scale, then we can say for sure that it's not collinear. But there's not enough information there anyway. So I'm gonna say nope. Any 3 points have to be coplanar, but they don't have to be collinear. The next one, we have AE and GE are parallel. Now, you've done the definition of parallel before. So these two lines here, are they parallel? Well, do we have enough information to say they're parallel? We do not currently. We'll do a lot more parallel lines in the next chapter, actually. So I'm going to hold off on explaining that one. I will not be asking you that question on the test. All right, and then 22. AB lies in plane S. Okay. Points A, B, Z lie in plane R. Point C does not lie in S. Describe the intersection of plane R and plane S. Make a sketch to support your answer. State 3 postulates that support your answer. All right, so think about this. Line AB lies in plane S. AB lies in plane S. All right. Points A, B, and C lie in plane R. Point C does not lie in S. So I would say that so far we know that AB is in both planes. So that has to be on a line where they are intersecting. Point C does not lie in S. Describe the intersection of plane. Yep. So again, A, B are going to be on the line where the planes intersect. The other 2 points, sorry, not the other 2. C will not be on that same line. C will be on plane R, but not in plane S. So you could draw another diagram similar to what they had up there, or the one that I drew earlier. So that's A. That's B. We can see that this is point C over here. C was on plane R, so we're going to call this plane R, and not in plane S, so this will be plane S. And that's it. All right, so again, next section will be in the next video.